So a spring triangle is a system where there is a rigid support on one side, moving fixed length side. It moves like this through this angle, and a spring on the third side which changes in length as this side moves. And you see it forms a triangle. So in order to solve this kind of problems, I wrote this code and I will demonstrate how it works. So this, let me load up a sample problem. So this is the spring triangle problem we've solved. As you can see, this is the triangle, this is a fixed support, this is a moving arm. So demonstrates length of spring is 0.2, spring constant is 8, vertical force 300, advice rate is negligible. What is the angle theta? So this is basically asking at what angle will this system be in equilibrium. That means the moment due to this will cancel out the moment due to force. So in order to solve this problem, I decided to use a method where I impute a series of angles, random angles, until I get one where that causes the moment of this to be equal to cancel out moment caused by this. So basically using angles to find moment. So let me run this program. I explained how it works inside the code. So if you're interested in that, just download the code. So I'll enter a random. I've done this before, so just for demonstration, 105 degrees. Spring constant 8,000, 8 kilonewton, and length of one straight spring 0.2 meters, and distance of spring attachment to that is this, not distance of the hole but just where the spring attaches, 0.24 and 0.24. Distance of force from origin of bar, which is force from, I like to use this pivot as origin, and I measure angles from the vertical so that I can easily get the direction of this force due to spring. The direction of force due to spring changes with this angle theta. So the force is at 0.48. 0.48. Why is it not writing? 0.48, yes. Is up here. If this is your origin 0, 0, 0, this is 0. We're writing it in vector form. I put points here instead of comma. So external force on the moving arm, which is this here force, 300 newtons downward. So we enter it in vector form. So this is just a warning, not really an error, so you can just ignore it. So as you can see, the moments due to spring and force they are almost the same but not quite, meaning that we may be off by a couple of degrees. So we just try again. So I made a little error. I'll just have to run it again. The correct answer, okay, 8. I entered 800 instead of 8,000. 0.2. So you see that when the spring constant was 800, this moment due to force was way more than this, so it's not quite in equilibrium. It will keep going down. 0.48. So coordinate of spring. So you see, the numbers are quite similar. So it's fair to assume this angle is correct. Yeah. Let's check the answer from the textbook. You see? Now you see the answer. This is quite important part. The answer for this question is 18.6. So how come what I got was 108.6? Have I just been wasting my time? Have I wasted your time? Well, don't worry. What happened is my program measures angles from this vertical. This is because it makes it easier to derive the direction of this spring force. This spring, like the force direction, constantly changes with angle because the length of the spring changes as you move it up. Yeah. So in order to get this angle, you see this is 90 degrees. So we just have to do this answer we got here. 108.6 minus 90. Yes, so you see we get 18.59, which is basically 18.6, and well, that's the answer here, isn't it? So yeah, I haven't been talking rubbish. So yeah, this is another question. You see, it's also a spring triangle, but it's quite different because this point isn't directly on this line, so you have to compensate for this additional angle, but I explained all that in the program. Yeah, so you can just try this. Yeah, adios.